Hello everyone and welcome to another video. Building off of our data frame benchmark test that I created this dashboard around, where we are looking at the data frames, pandas, polars, and narwhals, I basically was able to show the times and where each of them has its strengths and which of them has its weaknesses and what areas. But what I wanted to do in this video is to kind of build out a actual implementation of one of these and kind of work my way through them. So we're going to be starting with data frames in pandas, where we're going to be building out this interactive map and this interactive -ag grid table, which allows us to plot maritime data from an Excel sheet directly into an interactive dashboard that could be used to show, like as you can see here, latitude, longitude, air temperature, wind speed, and other different metrics associated with the data set that I'm working with, which is from NOSHA. So with that, I want to kind of dive into the code and we kind of look at this together and how I was able to build this out. So starting in the Pandas Excel, this is the application that I just shared. Basically what I'm doing here is I have the imports that I'm using. Obviously I'm using Dash, and I'm using a lot of the Dash different components that are provided within that, like DCC, HTML, input, output, state, and callback. I am bringing in -ag grid, which is one of Dash's very popular packages which allow interactive tables. Below that, I am using pandas, and I have Plotly Express, and then Plotly Graph Objects, Base 64, and IO, which are going to be used in parts of just cleaning the data that I'm working with. So I'm initializing the Dash application with dash.dash, where I provide the name, and then I'm suppressing callback exceptions just to keep the errors from showing up, because this is a rendered on a request of an upload, so it's just a clean way to go about it. Outside of that, I have an app.layout, which is basically going to create the container for my application. You can see the HTML text right here, which is in my app. Then I have this upload component, which I'm using DCC upload. I provide an ID to that, and then basically you can drag in a file, and that will be used to build out the table and the respective map. So below all of this, I have a container, which is going to be used to render the graph, and then I have another container which is going to be used to render the table. Lastly, I am using DCC store to manage the data within the application itself. So this is local storage of data using the DCC store, which is a very powerful tool also provided by Dash. So just to kind of show how all this is working, first we can see that I have this parse content. This is going to be used with the DCC upload, and basically what it's doing is it's taking the contents in the file name, and then it's using base 64 and base 64 code to decode the file itself and to allow it to be used within the Dash application. So working our way down, what I am doing here is I have a few callbacks. I have an update output. Then I have a create initialization of the visualization. That's a mouthful, but basically this is going to be the initial render of the graph and the table, and then I have a few functions, which is going to be related to the graph and the grid. And then lastly, I have another callback, which is going to be updated depending on what I do in the table itself. So we will kind of work through this in order to kind of explain this a little better. So on the update output, this is going to be taking in the upload data, and then it's going to be saving that data in the store. So the DCC store is where this is going to be sent to. Now, this is just basically creating a data frame from the parse content, where it's going to copy the data frame, it's going to use pandas, and it's going to just make sure that everything is going to be brought into the DCC store. Now, working our way below that, we have the create the initialization of the visualization. So this is going to be focused on the store data is going to be the input. So whenever the store receives the data, then it's going to start this next callback. This callback is going to update the graph container, and it's going to update the table itself. So with that, you could basically see that it's creating a pandas data frame from the data of the DCC store. And this data frame is going to have some cleaning that's going to convert the time to what could be read via Plotly. So it's basically just going through the time of observation column, and it's going to basically turn that into a to date type of object. Then it's going to run a function, which is going to be the create graph, and then it's going to run another function, which is going to be create grid. And then lastly, it's going to return both of those in the outputs that we can see right here. So scrolling down, we can see what these create graph and the create grid functions consist of. So the create graph function is going to be looking for the latitude and longitude, and then it's going to see if there are any latitude and longitude values that are missing. Then it's going to run the data frame drop in A so that it will remove those bad data sets from the overall data frame that we are building out so that everything is clean. Then we are basically going to create a hover card for the data set. Whenever we hover over the map, it shows the information that we would be wanting in reference to the data and to the map and where everything is located. So with that, we create this figure, which is going to be a PX scatter map. So this is Plotly's graph, which basically creates a map where we are passing through the data set itself. Then we are specifying that you're going to be wanting to reference the latitude and longitude of the data. And then for the hover data, we're going to be using that hover data card that we just created right here to pass that in so that we have that hover effect on the data whenever a user moves their mouse over one of the dots. So then we are basically defining how much zoom we want into the map, and then the height of the map, and then we're giving the map a title. Lastly, we are doing a figure update layout, which is going to basically define the style of the map that we want to show, and then we are giving margin to the map, and that's what the update layout would be used for. So this is a catch-all to just say that, like, if no data was found, then just to render something, just to inform the user that nothing was found. And then lastly, we are returning a DCC graph where we are passing through the figure. Now for the grid, building out the AG grid component, we are kind of following through a similar format where we are creating a data frame from pandas. Then we are creating an empty list that will be built out from the data. So as this is the data, we create a loop which will basically look for the columns, and it's going to define the columns that we're going to need to build out the table. And then we are going to basically adjust the width and the design of the -AG grid columns based on this time of observation, because that's a mouthful and it's a large name. We're just going to make that a little bit larger. So with that, we're just appending these columns to the column definitions. Then we are returning the -AG grid as a component where we are passing through an ID for the grid. We are updating the row data. We are updating the column definitions that we just defined. And then we are giving some style attributes to it, and then some grid options for example, pagination, the size, and then the auto height. Then we are also providing a style just to keep it at 500 pixels, and then we are using the class name to define the color of the AG grid. So lastly, we have the update graph from the grid. So basically, whenever you make a change to the -AG grid, then it's going to automatically update the map itself. So as you can see here, we have an input, and then we have a state, which is going to be the data. The input is going to be the -AG grid, and then the output is going to be the graph itself, where we're going to be updating the figure. So as we can scroll down, we can see that this is also just basically going through the same method as above, where it's just recreating the data frame. It's doing all the same things it was. It's cleaning out the latitude and longitude. It's dropping those columns if they don't exist. It's creating the hover card for each individual data point, and then it's creating the scatter map for the actual graph that is being rendered. Then that is going to be returned into the figure, and that is it. So with that, I know that that was a lot to kind of cover, but what we have here is an interactive map and a tool that can be used to host on a application and a server so anybody can access it, which is perfect for taking your Excel spreadsheets to that next level, being able to share it internally with other coworkers, or to be able to host it in an application that anybody can reach to see the data science and the stories that you're trying to tell with the work that you are doing. So that's pretty cool and exciting. And for 300 lines of code, it's honestly not that difficult to get it working. What you can do to help support this is to look in the documentation, as there is extensive coverage on all of these topics, and the pandas data frame also has a lot of documentation associated with that. Or you can also look into the Dash Plotly form, as this is something that a lot of people work within to get more reference and tools to better work within this stuff. Outside of all that, you can use AI to expedite the building process and just give it the direction and the prompt to start building it out and to work from that. But with all that said, I hope that you found this interesting. Please like and subscribe if this was. And as always, build something amazing. And I'll see you guys in the next one.